background. Last but not least, we are the CERESS team.
Yes. A little excuse for the presentation. We just received. No, we just received lesson in the evening, in the pub evening, that we have to do a presentation, so don't be too hard. Oh yes. Okay. What you see is our project channel, spreadsheet, sorry, and it got some numbers in it that are very important to our experiment. Before we explain the experiment, we better explain some numbers.
Yeah, but before you know the numbers, you have to know what is inside the experiment. So we have this nice diagram here.
And the spreadsheet is all about basically this.
So that is the rocket module. We have some sensors and electronic stuff in there, which is really important. In addition to that, for that you need the telemetry budget. Really important.
But don't be too concerned, because we're not just two. We got 2 other team members helping us.
Now I'm Daniel.
Me, Sebastian.
And the other 2 are some in the back there.
Alexander's there.
So we are the team CERESS. It is a bit boring, so we don't have any fancy thrown things to throw. But let me do it interactively. Who is for the teams responsible for the power system? Hands up, please. In every team. So who is responsible for the onboard data handling? So that is the point. Like every team has these persons. That is the thing.
So basically, we analyzed the REXUS experiment at the university of the former experiment, and it was basically like this. You have the REXUS service module and your experiment, and inside the experiment there's a whole lot of infrastructure just to support the experiment, like onboard data handling and power supply and data storage. So that's all work that needs to be care of, that takes work power away from the actual experiment. Like
that is that.
This is what we try to achieve, to develop a generic sensor bus, so you can plug your experiment on top of it, and it does the handling for you and the data storage, and you can then do better science and not just working on the infrastructure.
Yeah, now you see, technical stuff. You all know, like, a major part for considering, especially with the CERESS module, are the interfaces. And so we go through a lot of effort in configuring them properly. And so you see all these are interfaces. Some are two-way, some are one-way. Because like this is the flight mode from your, in our case, verification module, where we later will be the experiment. Right now we have sensors on them to verify them. Though other teams in the future can use verified sensors already. So from there to the rocket modules, which will later be the CERESS box to use. From there to the service module, ground station via up and down link, to your own ground module, and in our case to a visualization tool, which we will explain later. On ground, there's a SD card removed from the CERESS to the ground module, so that is a one-way because we take it up. And of course, the last-minute service updates and whatever you have to do with a service computer is a direct interface to you. CERESS rocket module as well. And that is how it looks like, hopefully. Here we have a shielding box. In there is the latest CERESS rocket module. Everything else around is, in our case, the verification module. We will fly some vibration sensors, pressure sensors. With these, we want to do an altitude determination. and a camera. In our case, since we don't have an experiment to film, we just film the outside because it's way more interesting than light inside. That will be the inside then of the shielding. 1 gyro and 4 accelerometers in a tetrahedron configuration.
You maybe should mention that we'll have a basic instrumentation of sensors flying in every rocket module. So that's data of almost every experiment to now needed on every flight. So we just include them into the module, not in the verification module.
So these are these. And the tetrahedron configuration is from, like, if you have 3 accelerometers, you can calculate the rotation rate and so on as well. Except that just take the gyro, so we have there redundancy. The third one is redundancy for the accelerometer. Since one failed, we still have a perfectly shaped triangle.
Yes, and this will be the final outcome of the CERESS project when we take the verification module away. For future teams at our university, you will have the rocket module that you can use to run your experiment, and you just build the experiment. You have a set of even more verified hardware that you can choose of the shared products to use, and you will have the fancy visualization tool, which is inspired by the NASA stuff. So we will try to get some trajectory and some flight information like altitude and speed. This will be available in post-flight, guaranteed. And if we can make it work in the Google Earth plugin, we can stream the data live to the internet server. And through the Google Earth plugin, everybody in the world can watch the REXUS rocket fly live. So if we make it work, we will promote the plugin to every REXUS team, and you can spread it to the university, to your friends, and everybody will see what cool stuff you do. I see some smiles in Mike.
Then we'll crash the server because it's overloaded, and yeah, that'll work. That'll work great.
I said if we can make it work.
That's it.
That's what we do.
So, questions?
Let's see.
Any questions? Oh, sponsoring.
The number of coffee you drink to prepare the presentation?
No, for the project.
Per person?
Yeah, we
The person for something.
educate. Like, if you had paid attention, the more it was less than that one. Last presentation.
So at each presentation you're gonna update it?
Yes.
Educated
It's
guesses.
like a campaign. Interested. I don't know.
We can make a nice draft at the end.
Anybody else?
Yeah, your experiment is something like an interface for future experiments, right?
Yeah, exactly.
So, let's say, will it be something like freeware or shareware? Because will it be a module just, let's say, speak honestly, for your university, or is it also possible that future groups from all over the world can ask you for this module, or
Yeah, we
how
have
you will
that
handle
exactly
it?
in our PDR today. Right now it is planned for our university, since in the other cases we have to do way more, and it has to be even more reliable and more configurable. It has to be more possibilities to configure it. And, it's next step.
Yes.
Are you worried about lack of well-trained electronic engineers out to do all this for your new practice?
No, things like in our institute we are like the 5th group already on a REXUS campaign, and from now till now it was just from the Institute of Aerospace Technologies, and so we want to promote it to other.
Oh no, it's okay. I was trying to count how many ones I had. 2 or 5. I ended at 4.
So yeah, we are a big university in Munich, and there are other departments who possibly are interested, but right now like the physics department or the geodynamics, whatever, who knows what they come up with, and they have the infrastructure.